Hi. So as in my last video, I have told that I'll be using the DHT11 sensor, this one, and I'm going to create an application of this where I'm going to use LCD screen and Arduino Nano to read the humidity and temperature in the current surroundings. So let's get to the video. Okay, as we see here, as we're saying here, we have the LCD screen attached to the breadboard, and this is your Arduino Nano. I can just show you the pins. So as you can see, this side we have our digital pins, and the other side we have an analog pin, just similar to our Arduino Uno, which I am showing you right here. So but in this project we're not going to use Arduino Uno, we're going to use the Nano. But this circuit is going to have very complex connections, so I'm going to show you step by step of how to make the sensor and the LCD screen and the Nano along with the potentiometer to fit in this breadboard. So I'll just take the potentiometer and just keep it so that you can see the whole video. I'll just place it somewhere here because my potentiometer is only going to be used for the LCD screen brightness, so I'm just ensuring it to be close to the LCD screen. And my sensor, I'm just going to place it here, just like that. Okay, I hope you can see it. So here now these two I'm just keeping it a bit far from my LCD and my nanos because the LCD wire connections and are way more complex over here. I'll just show you step by step, so please do follow it. So first we are going to start from the LCD screen side because the potentiometer and the sensor is just basic connections. So the leftmost pin, which is the VSS, I'm going to connect that to the ground here, and the VDD pin, I am just ensuring there's a gap between here so that the connections are clearly visible. So I'm connecting this to the positive 5 volt end, which I'll explain to you the end why I'm doing it. So now comes the mixing up of part where I'm gonna connect the output of my potentiometer to the third pin, that is V0 here. So now you can just complete the potentiometer's connection. So we have the VCC which is for 5 volts. I'm just giving it to the common there, and the ground here. Actually I'll give it a bit closer because we have another ground connections, not just another, we have more. And here I'm just going to show you, let's just take this. So the fourth pin, that is the RS, we connect that to the 7th pin, that is pin number 7 of the Arduino Nano, and the RW pin is again a grounding connection. Here I'm just giving a gap so that it's easy for you to understand the connections when you're doing it. And after that we have another connection here, so that is the EN. So I'm connecting that to D8, I mean that is the digital pin of Nano 8. Okay, so you see these wires crossing here, there are many more wires that are gonna cross, and it's gonna get complex. So step by step, if we don't follow, we're gonna make mistakes in the circuit connection. I myself have faced a lot, and have come to this clear connection. So the next we are going to use from D4 of the, here if I can show, yeah, so the D4, D5, D6 and D7, A, K. So these 6 pins of the rightmost side, we are going to connect it to the nano, and we have 2 pins that are connecting to the ground as well. So I'll just show the ground connections first. So the first pin is ground pin, the negative end, so we have that, and the second pin goes for 5 volts connection. So the remaining 4 pins, I'm gonna take a bigger wire because the connections are too far away, as you can see. So I'll just go from D4. So D4, I am gonna connect it to D9 here, and the next one, I'll just take a red wire. So next one here now. So D5 is what I am gonna connect to 10, and then we have D6, which I'm connecting it to 11, and then I have the D7. It's just too complicated here with all the wires mixing up. So as we see here, we have the connections made for the LCD potentiometer and the Arduino Nano. Now the most important thing that we have to ensure is these cable connections not to get tangled or disturb any other connections over here. So now what we have remaining is our sensor getting connected to the Arduino Nano. So we have 2 grounds for the Arduino Nano that we have to connect. So first one is here down, so I'll just connect that to the minus here, and so the sensors, we have the positive, negative and the signal reading connection, which I'm gonna connect it back here. If there's no space, you can just move it a bit front, yeah. So the minus or the negative end will be going for the ground here, and the positive gets connected to the 5 volt common connection, as you can see here. And now the output, that is the signal that we want, I am connecting that to the second pin of our Arduino Nano, that is the orange cable, as you can see here. So just ensure that every connection is just done very carefully. Now we have another ground for the Arduino Nano, which is here. So I'll just keep it here. Oh, sorry. So here, and I'm connecting it to minus. Yeah, and the 5 volt that we have, I'm gonna give it here, but we have to connect the 5 volt common for the LCD screen as well as the Nano here. So I'm just using another connection and just connecting from this end to this end. Yeah, so this cable I'm just connecting both the plus connections. So as you can see here, this is the final circuit connection that we have for our project, and to ensure that it works fine, we will just connect it to the laptop. I'll just keep it this side so that the connection is easier to the laptop. Okay, so we have the Arduino Nano connected, and it's detected by the laptop, and even the LCD screen is working, so the circuit connection is done correct. Let's just check it by like increasing and decreasing the yeah, here. So as you can see, there's already my output shown here as temperature in C, that is Celsius, for 29.4. That's my current temperature in my room, and the humidity is 75. So I'll show you in code how to get the output in C as well as F, that is Faraday. Okay, so this is the code, but before we enter into the code, we have to make sure that we select our board as Arduino Nano here. Arduino Nano. Let me just get my focus clip. Yeah, and our port also we have to make sure it's connected. So it's COM4 and it's connected. So let's just get into the code here. So as we can see, I have declared hash include dht.h, which is the library header file for the sensor, that is dht11, and I'm defining the type as dht11. And here I'm including my liquid crystal.h library header file, because I'm using the LCD screen over here to get the output values. So here int rs en d4 d5 d6 d7, this I've showed you the physical connection from the LCD screen to the Arduino Nano board, and we are creating an object of liquid crystal that is known as LCD, having all our parameters here which are connected through these numbers, and we can change these connections later as per our requirements. And the next declaration that I have given here is for the sensor output pin, which I've connected to pin 2 of the Arduino Nano. So here the DHT HT, here I am giving sense pin and type. So this is basically to just recognize the connection and give the proper output, just sensing the pin connection which we are giving, and along with the type of sensor we are using. And I'm declaring as humidity temp C temp F, which is I as float, because we always get decimal values of our temperature and humidity. Temp C is for Celsius, and temp F is for Faraday reading. This set time is equal to 500 here, which is my delay. And coming to the void setup, I have serial.begin at 9600, and also I have to use HT, sorry for this. Yeah, so here I have ht.begin. This is for the sensor to work and read the values, and I have a delay set here so that it takes some time in the middle to read the exact value present in the room. And then I have lcd.begin, and I'm just declaring that it as 16,2, so that my output knows that I'm reading it on a LCD screen of 16 rows and 2 columns. And here comes the void loop. So in void loop we have to calculate the humidity temperature. So for humidity I have humidity is equal to ht dot read humidity. So this read humidity is an inbuilt function and which we can use to calculate the humidity. And same is with temp C is equal to ht dot read temperature. So read temperature is also similar to read humidity, and it's the same, like it's a inbuilt function that we can use. So read temperature over here in this statement gives you the Celsius reading, and for Faraday we just have to add true in the bracket. And here we have the LCD set cursor. No, set cursor as 0 comma 0. So this will be the first column where we are going to display the temperature. So right now I've just given here as temp C, and I'm calculating it for Celsius. And the next line, that is the next column of my LCD screen, is going to give you the humidity value. And here I have another delayed time so that we can read the values clearly. And my LCD.clear screen is to clear so that my values can be read properly in the loop and not just keep repeating continuously, which makes it difficult to read. So by just uploading this code, we can just check the values. So it's done compiling and it's uploading now. So it says that it's uploaded. Let's just check here. So currently the temperature in my room is 29.2 Celsius and humidity is 76. So I'll just keep it here, and I'll just show you this now. So the temp C, what I have here, I'm going to change it to temp F, and here I'm going to change it to F to get the Faraday value. Let's just see if it works. Let's upload it. It's done compiling. Let's come here, and yeah, so we have the temperature and the Faraday value is 84.56 and the humidity is 76. So yeah, this is the end of the video, and this is my application of the sensor, where we can connect it to the LCD screen and view the temperature and humidity over here. Now this is just a prototype on the breadboard. We can solder this to the circuit as a PCB board, and also give it and place it in a room. So right now this is going to be in my room. I'm going to read the values every day. Thank you.